Hello everyone, welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to analyze COVID-19 tweets, right? So we are in the year 2021. That is after COVID-19 has passed for almost about a year. So we're trying to see how to analyze and derive some insights from COVID-19 tweets available on Twitter. So I got the dataset from this particular URL. Gabriel Prada, right? That is a very smart guy. He created a simple script that is able to extract a specific data from Twitter, right? So you can actually go to the GitHub page and then get the script and use it, right? This is the guy. So that's where I got the data from. He's one of the grandmasters of, or he works with grandmasters of Kaggle, right? Kaggle is a very powerful website. So let's see what we're trying to do. So the data set is already picked from here. So that is what I'm picking from, right? So I did not create the data. I just got it from his place. So let's see how to analyze this data. So we'll be using some powerful tools to help us with that. So as usual, we'll be using the almighty pandas. You may be hearing some noise behind this video, but we'll still go on it, right? That is another bonus. So we'll be using some EDA packages. We'll be using pandas. So we'll be importing pandas as PD. Right, then also for these are the main ones that you'll be working on, right? So be importing pandas as PD as the main package you'll be using. We also be importing some data visualization packages, which we always use to be importing pandas. We'll be importing matplotlib.py plot. We can also use Plotly Express, so we can also import Plotly Express, but let's not use Plotly Express. Let's go with Seaborn. So import Seaborn. Apologies for the noise you're hearing behind. Anyway, that is the bonus. Okay, so that is all that we'll be using for the data visualization packages. So I'll just run this, right? And then let's import let's hide errors. We'll be hiding all the warnings we'll be having. So it's going to be import warnings. Then from warnings, you're just going to be hiding warnings.filter warnings. Let's ignore all the duplication errors, right? So that is something very simple. Perfect. So that is also, let's load our data set. So the data set is already within our folder here, which we have already seen where we got it from. We got it from Gabriel Prada, one of the grandmasters of Kaggle. So we are going to be using this particular data set right from here, which is a COVID-19 data set, so you can have access to it. Right. Okay, so let's go back, and then the data, I've already copied the data, which is this one here, so it is quite big, so we'll try and see how to work with it. So just go back again. So df pt.read_csv into my data folder, then I'll just copy that particular file, which is the COVID-19 tweets, right? So COVID-19 tweets, right? So perfect. So there's a data set. It's quite huge, so you just take some time, right? Our 65 megabytes. So I'll just go back and let's preview the dataset. You can also use PySpark, right, to also do the same thing we are doing, but maybe another time we try and see whether we'll be able to use PySpark to help us with that. Right, perfect. So df.head, then I'll just preview it. So if I check it out, we can see that we have, see what I did. Yeah, it's still working anyway. So we have gotten our data set, right? So this is just going to give us the data set, and you can see the data set is having some very nice information there, right? So we're trying to see how to derive insight from it. So looking at this data set, we can get the top users, right? Username, the most common username, can get the top location, right? That is another question we can also get from. We can also get the tweet. Can also, the sense there is user friends, user favorite, you can do all of those things, but let's concentrate on the test, right? So that's what we're trying to do. So we're concentrating on this particular test option. You can also use the day to do some maybe time series analysis, but we'll concentrate today on the test and then the categories, right? So let's check it out. So I'll go back again and let's see what we'll be doing. So the task we'll be doing is that we'll be picking the test column, right? Then under the test column, we're going to see how to do some simple test pre-processing to clean it, right? Then the next one that we'll try and see whether we'll be able to derive insight from it by checking on the sentiment analysis. Then we can see whether we can get the keyword extraction, keywords, right? Then we also see whether we can be able to extract some entities from it. So entity extraction. right? So these are the basic stuff you'll be doing from the test column, right? So let's check it out. So there are some questions you can ask, the longest tweet, all of these things. So I'll just go back again, and then let's check the columns. So if I check the columns, it's going to be df.columns. Let's check all the columns. So these are all the columns that we have on our data set, right? So I'm going to pick the test column, right? And then there are a lot of insights you can get, but you just want to make it simple for today. So I'll go back again and I'll pick. So let's check the data type to see what we have. So df.dtype to get the data types. Very nice. That's all. Perfect. So we just get the test column. So I want to pick the source column, right? In the source column, we have different format of data, right? So I'll be just picking that one as this. So just check the source column. So we're going to check the value count or distribution of the source of data, right? Where is the data coming from? So the source include, is it coming from a mobile phone? Is it coming from Twitter app? Is it coming from maybe an Android phone or something? So if I go back to the source here, I just go .unique. So this is going to give me all the various types that we have, which is quite a lot, right? So you can see that it is coming from different places. So we have Twitter for iPhone, right? Twitter for Android, Twitter for web apps, Twitter for iPad. These are all the different places that the source of the tweet is coming from, right? So some people are even using bots to be generating the tweets, right? Very cool. So you can actually do a value count of this particular place. So I can just go back again to this that we have, and then just do a value count of it. So just go back again and just go with value count. If I go with value count, right? So apologies. So you can get a value count. You can see that Twitter app, web app is the highest, right? So the best way is that you always have to visualize what you are seeing, right? Let me reduce myself because it looks like I'm looking too big. Okay, so the best way is to visualize or plot this one out. So I can just go back again to what you have done, and then we can just plot it out. So we can't plot all the 1, otherwise it's going to be too much. So we can just plot the top 10. So in that case, can just go with, let's say, plot the top like value, right? So to do that, just go with my df.source .value count. If I go here, right, and I just go largest, right? We have n largest. So I want to get the top, let's say 30, right? If I go with this, it's going to give us the top 30. That is the highest numbers, right? So this is the top 30. Very cool, right? So you can see that Twitter web app is the highest, Android, iPhone, TweetDeck, which is a very nice service, right? Hootsuite, a lot of different services. Some people are even tweeting from Instagram. Wow. And then of course people are tweeting from different bots, right? So there are some bots here. So what I'll do is that I'm just going to pick this ones and plot it out, right? So the simplest way to plot this one is just go back to this place. I hope you can hear me. I hope the audio is on. Let's go back again. Plot. The kind is called to bar. Then I can just plot it out. So this is going to give us a simple plot, but we can make the plot better and beautiful by going with a Seaborn plot, right? So this is it, but I can make it bigger so that I can see it very well. So let's make this plot bigger. So I just copy this one here that we have. This is a normal plot in case I want to make it better, bigger and cleaner. Okay, let's come back again. Then just go with my plt.figure size. You can also put the figure size inside the plot, so it's still going to work. So let's make it like 2010, right? That's the first 10. Then I can just go back again, plt.s text. So I want to make sure that these things that we are seeing here, these names are too long. I want to slant it, right? So we can also do the same thing here by coming back again, rotation. It's equal to 45, right? Then now I can just plt.show. So if I go with this option, it's going to plot it in a very nice format for us. The same plot that we had is giving us an error. So let's fix it out. So the reason it's giving us this plt is that plt is not defined. So I just go back again. We forgot to define it. Import as plt, right? That is what we forgot to do. So I just go back again. to what you have done, and then I'll run it. So if I run it now, it's going to give us a very nice plot. Right, perfect. So you can also see from here that this is the plot, right? So Twitter web app is having the highest, followed by Twitter for Android, Twitter for iPhone, right? So in case you want to know where people are actually using Twitter, right, you can see that people are using the web app, that is the website, Android, iPhone, Twitter deck, and the rest. Very simple. So that is something very basic we have done on the source, right? Now let's move on to some other stuff we can also do. We can also check on the test. So I can just move on to test analysis. It's going to be my test analysis. So we are working on the test itself, right? So what we'll be doing is we're trying to process that particular test that we have and then work on it. So it's going to be on this. So test analysis of tweets. So you have to first of all process it first. So it's going to be we'll be using neat test to help us with that. So in case you don't have neat test, you can just go back with this option. So pip install neat test. Right, so neat test gives you the option of doing a lot of cool stuff. So in case you don't have, you can just install neat test. It's going to make it easy for you to do your test cleaning. So let's load our test cleaning package to help us with the cleaning of our test. So if I go back again and I just go it, so from neat test dot functions import, or let's say you can import a lot of things, but let's import it as one. So import neat test dot functions as NFS, right? So in case I want to see all the basic things you can do, you can just go with my DRL. This is going to be the methods and then the attributes of this particular package. So df.drl.nfs. If I go with this option, you can see that there are a lot of things we can do with this wonderful package. You can see all the basic regular expression. So we have the dates regular expression, email, emoji regular expression. So in case you want the type of regular expression for your code, you can also search for it. You can also see all the basic stuff you can do when you're trying to work with it. You can extract stuff, right? All of these things you can extract: stop words, hashtags, extract emails, extract emojis. You can also remove them, right? In case you don't want them, you can remove barcodes, remove Bitcoin address, remove emails, dates. You can remove hashtags. You can remove stop words and phone numbers, all of these things. So be trying to see how to remove stop words, special characters, and all of these things. So let's see how to work with this particular package. So I'll just come back again. And now I'll just go back to df.the test column. If I check the test column, you can see from here that it's having a lot of things here, right? So we have some hashtags here, right? No, this is not a hashtag, but this is a mention, right? We also have some special characters. So let's see. Let me pick one. Yeah. So let's pick number 2. So you can say we have some mentions here, right? This is a user or the mention. We also have Covid19, which is a hashtag. We also have some links. So these are some of the things we are supposed to remove. So you're supposed to clean, or we can call these ones as noise, right? So the first one that we are supposed to remove all mentions, right, or user handles. We are also supposed to remove, let's say, hashtags. And of course, there are URLs you are supposed to remove. There may be emojis we may also want to remove. There may be also, let's say, special characters. Right, so these are the things that they are noise that we can remove from our test, right, to make our test more cleaner. So let's start with it. So I'll just go back again and let's see how to first of all remove it. So it's going to be my df.test, right? Now I just go with this option. So I can just go back again. So we realize that if I go back to the app itself, right, the file, and I check it out, we had a column called hashtags, right? Hashtags. So one of the things we can do is that we can actually compare the hashtags within the test, right, together with the hashtags that is already given by the hashtags column. So how do we do that? So you can also use this wonderful package to help us, neat test to help you with that. So I can come back again and just go with my apply, right? Now I just go with my nfs dot, this is a first method. Then I'll just go with or extract hashtags. Right, so if I go with extract hashtags and I run it now, that's it's going to give us, it's going to go throughout the entire file and extract all the hashtags within our test column for us. And then we can actually compare the extracted hashtags to what we have, right? So we can just equate this entire stuff. So let's give it as df.extracted hashtags, right? Column. Then I'll just run this one. Then I'll just compare it with the original hashtag we know to see whether we actually got the same thing. So it's going to be my df. It's being like this. It's going to be my extracted hashtags. That's the first thing. Then the next one is going to be my hashtags. Right? If I check these two columns, you can see that they are almost the same, right? They are actually almost the same. So the hashtag is here, right? The same thing here. COVID, week max, where max. See, very cool. So that means that our app, no, our function was able to extract and identify the hashtags, and they are the same, right? Very simple. So you can actually find the percentage that is the same and all of these things. That is another thing you can also do. But let's move on to our test, right? So I'll just go back again and let's do some cleaning of the test. So I'll just go back again and then let's first of all remove the hashtag, because we have realized that there's hashtags there. So can I just go back with apply, then nfs dot remove hashtags, tags, right? So you can just go with this. So let's equate it to this. Let's go to clean. Let's go tweet, right? Because it's a tweet instead of test. So it's going to remove all the hashtags and store it inside this particular variable called or column called clean tweet. So df. Then I can just go back again and compare. So we have my test itself. Then I have my clean tweet. Right. So if I go back and I check it out, you can see the difference between the one with the hashtags and the one without it. You can see that now it has removed the hashtag. So the one COVID it's gone, the one gift is gone, right? So all the hashtags have been removed. Now you can also do the same thing and then remove out the mentions. So let's see how to do that. I'll go back again to what I have. I'll just go back. Same thing. So clean tweet. Then df. I'm now using the clean tweet so that we don't need to repeat ourselves. Then I'll just go back again, dot apply. This is another way you can also do that. NFS, you can just go with like this. So lambda, this is another way you can do that. Lambda s, right? Then NFS dot remove. This is another way of user handles. Now passing my x. This is another way. So you can see that the user handles is the same as the mentions. If I go back to check the attributes for the app itself, apologies if my voice is too much in your ears. We have remove hashtags, and then we also have remove user handles, right? So you can actually remove user handles from it. So we can just go back again and run this, and it's going to remove all the user handles from our clean tweet so that we have a very different one. Right, perfect. So if I go back and I check it again, you can see that now all the user handles have been removed because we don't need them for this particular case, right? So all the user handles, hey Yankees at Yankees, so it is gone, right? Very simple. You can also remove all the white space. You can see that there's some white space between them. So if I go back and I check it out again, so let's go back again. So df dot clean tweet. Let's pick number 10 or something, right? It's supposed to be, yeah, so there's some white line here, right? So we need to remove this white line. We also need to remove these URLs that we have here. So let's try it out. So it's going to be, copy this one again. Let's use a simple one. Copy this. You can use the same thing because it's the same thing. Need test to make it very easy for you to do the same thing. So I'll go back again to the clean tweet, right, in the same place, and then from here I can just go back again and then let's remove multiple spaces, multiple spaces. multiple spaces. It's going to remove all these multiple lines from it. Yeah, take some time. Then if I can just go back again and check it out, so I can just run the same thing that we had here after it's finished to see the difference of what we have done so far. Right, perfect. So if I go back and I check it out, see that now the white space or the new line, right, the multiple space is gone. Right, very nice. So the next thing we need to do is remove the URLs. So I'll just do the same thing, and then let's remove the URLs. Hopefully it's able to identify them. So I just go back in, remove all URLs from our test. We don't need them. Go to remove all the URLs. Then the next one is going to be removing punctuation. So remove punctuations, then we'll try and see how to do sentiment analysis on our test, right? Okay, so let's go back to what we have done so far. So now just go back again, and then we can now remove, let's remove punctuations, right? So let's say clean test. This will just give it as remove URLs. This is going to be remove multiple white spaces, right? And this is going to be remove punctuations, right? So we can also do the same thing. So I can just go back again, remove punt, right? So I'm running this one to remove all punctuations from it. Then later on we just do our test or sentiment analysis. So that is the next thing we're going to be doing. It's going to be my sentiment analysis on the entire test. Analysis. We have actually cleaned our test, so we can actually apply sentiment analysis on our test. So let's go back and compare what you have done, the original test together with the clean tweet or the clean test, and then we can work on it. All that you have done, you can just combine them as one, right? But let's move on one another for the other. If I check it out, now this is better, right? Everything is better. So all this unnecessary words have been moved. All the other things that we don't need has been moved, right? You can actually take out special characters in case you want, right? That is in case you want. Now let's move on, and then let's do sentiment analysis. So I'm going to be using test blob to help us with that. So let's work on it. It's going to be from test blob, import test blob, right? So test blob is going to be used to help us do sentiment analysis, right? So I'll just go back again. I'm going to create a function called get sentiment, right? So this function is going to take in my test that I apply. Then what is going to do is going to create a blob for that particular test. So test blob of the test, right? Then when it takes a test, it's going to generate our sentiment. So it's going to have, let's say, my blob sentiment, right? Which in this case we can go with this option. Or you can make it simple like this. We can bring the sentiment here. So dot sentiment, right? Then I want to also tell me whether it is positive, whether it's negative, whether it is neutral, right? So how do I do that? So I can just go back and see that this is blob sentiment, which is going to be my blob dot sentiment dot polarity, right? So let's make it like this. So let's call that sentiment polarity. That's going to be the first one. The next one is going to be sentiment subjectivity. Subjectivity, right? Which is going to be my subjectivity. So we have polarity, we have subjectivity. Right, perfect. Now to be able to get the positive, negative labeled, right, I'm just going to go just if my sentiment polarity can spell polarity is greater than 0, right? That means that it's positive. If it's greater than 0, then I just want you to tell me that that is going to be the result, which let's go as my sentiment label, right? The sentiment label, if it is greater than 0, that means that it's positive. So it's going to come back again. positive, right? Then do the same thing. Else if the sentiment polarity is less than 0, that means it's negative. Anything less than 0 is negative. Label negative. Then last one is going to be else. Any other thing that is going to get, we're going to put that as neutral, right? Else, let's say sentiment label is going to be neutral, right? That means that if it is 0, right? So if it is greater than 0, it is positive. It is less than 0, it is negative. If any other thing else, put it as neutral, right? Perfect. Now let's create a dictionary to bring the result. So result is going to be a simple dictionary. So to make it simple for us, I'm going to specify my polarity, which is going to be my sentiment. Sometimes it's better if you have a lot of details, you just put them in the dictionary, then you just get them out, right? So sentiment polarity, right? That's going to be the first one. The next one is going to be my subjectivity. So subjectivity, which is going to be my sentiment subjectivity, right? Then the third one is going to be my result, right? So let's go to sentiment. Let's go to the sentiment itself. Now put in my sentiment label, right? So this is a simple dictionary. So what the dictionary is doing is that the dictionary is going to bring these things right out: the polarity, the subjectivity, and the sentiment together as the label, right? Then now let's go back and return this one. So return the result. So this is a simple function I've created. So let's test the function first. So I'm going to just pick something from the clean tweet.ilog. Let's pick the first value. Yeah, this one. Then I want to apply my function on it. So let's apply the function on this particular test. So if I smell the scent of hand sanitizer, this is a funny one. So let's go back again and just create my get sentiment. Now passing my df, let's equate it to a value. So let's say example 1. I'll just pass it here so that at least it's become simple. Example 1. If I run it, it's now going to pick this particular test and give us the result. So it's giving us an error here. So let's see the error it's giving to us. So sentiment object has no attribute sentiment. So let's fix it. Okay, so the mistake we are making is that because we are just doing it, so let's take it off from here, right? So that is the mistake you are getting. So I just fix it one here. Now it's going to work. Previously, so just giving us the polarity, subjectivity, and then this is negative because the polarity is negative 0.25. Very simple. So now we can apply this simple function you have created on the entire stuff. So let's see how to do that. I'll just go back again. This is going to take some time, so apologies if it's slow. I'm just going to go back to my clean. Let's go to this sentiment, right? Then I'm just going to go back to this option. So let's go to sentiment results. Then I'm just going to apply that particular function on the clean test function. So clean tweet function, the one we have clean dot apply. Then I'll pass in my get sentiment. So this is going to take a lot of time, right? The system may even freeze. So it's going to take a lot of time. So what I would do is that I'm going to just pick some values from it and then we work on it because it's going to take a lot of time. So let's run it anyway. It's going to take some time, but let's run it. Take some time for it to run. Okay, so it has finished. So yeah, that's finished now. So let's see what we have so far. If I go back and I check out the sentiment result, I check it out, you can see that now it has given us a dictionary, right? Which is very cool. So that is very, very nice. Now the best way is that we are supposed to split these ones into their individual ones. So let's see a simple way you can do that, right? So how do you split something like this, right, into individual components? So if I go back with this is the dictionary dot say ilog, see how I spelled ilog 0, right? If I go with this option, now it's giving us a dictionary, right? So how do you split them to get the polarity as one column, subjectivity as another column, and the sentiment as another column. So this is very simple to do using pandas. So I can just go back again and let's go to my df, right? Let me go to df dot join. The simplest solution is this. Let me show you first. So I just go with pd, right, dot pd, right, dot json normalize. There's a Python function called json normalize that takes in a particular value. So if I pass in this one here, right, if I pass in this, it's going to normalize them for us, right? It's going to give us an error, but no, it don't give us an error. So this is a simple function, right? So this is a simple Python function that allows you to normalize a dictionary or a JSON format and convert them into individual columns, right? So that's what we're trying to do. It's a very simple, powerful function. So let's add that one. So df dot join. We are going to create another column, which is going to be my pd.json normalize. And I'll pass in my df.sentiment result. So it's automatically going to apportion them into their right places, right? Then later on it's going to join them to my column. So this is going to take some time. It's giving us an error because we made a mistake here. It's supposed to be sentiment results, not result, plural. Perfect. So it's going to take some time. Then it's going to convert them to a nice format. Now we can actually analyze this sentiment that we have. So we can just get all the positive words or the negative words and do a word cloud of it. Or we can also do the plot to see how many negatives we have and how many positive we have within our data set. Take some time. Perfect. So we are finished. So now if I go back again and I check it out, dot head, there we have gotten some new columns added to it, right? So it has been pushed into their right places. If I check it out now, so now we have these additional columns added. So we have the polarity, subjectivity, sentiment, right, which has been unpacked, right, or normalized from this particular column here. So we can drop this one out. So what we'll be doing that, we want to get the percentage of the value count of the sentiment. So let's see how to do that. It's going to be my same thing we did. So df, back to this column, df.sentiment, right? Then I just go back again, dot value count. If I go with dot value count, you can get the value count of how many positive, how many neutral, how many negative, and we can actually plot this one out. So we can just do the same way we did. Can plot the entire stuff out. Dot plot. The kind is equal to bar. You can also use Seaborn to plot it. So if I go back again, I plot this one out. So we have this wonderful plot here, right, of our positive. So the percentage of neutral trends, percentage of positive, percentage of negative. You can also do another plot, the same plot, using Seaborn. So plot with Seaborn. It's going to be very simple. So sns dot count plot, and I'll pass in my df. And I'll pick the column, so sentiment. So this is another way you can also plot it, right? So we're using count plot from Seaborn to also plot this one out. It has given us a very nice plot, right? So there are more positive sentiment than negative, and they are more neutral within our COVID analysis. Now that is how to work with the sentiment analysis, right, aspect of our app. Now we can also do another one. We can also get a word cloud. So let's do some simple text analysis. So we're going to be doing the keyword extraction. So we can do keyword extraction for all positive words, for all negative words together, and see and do a word cloud of it. So we'll be doing the keyword extraction for positive words, negative sentiment, right? So that's what we're trying to do. So let's see how to do that. So, and we can do another one for the entire stuff. So this one's going to be general. So let's see the first one. So we'll try and see how to work with it. Negative sentiment. So it's going to be my. So let's call that all sentiment. So sentiment. Now let's make it like this. Positive. This was not planned for, but let's do it. So df. I just go back to the sentiment column. I'm going to pick any place that is having the positive, right? So every place that is having this is what I'm picking. Only that one, and I only want to pick the tweet, not the clean tweet. So clean tweet, right? Perfect. So this is another way we are doing. So we are just picking only that particular column. Then do another one for the negative and then neutral. But I think the best way is to just go for the neutral and the positive and the negative, because neutral is, yes, but we can still do the same thing. Neutral, This is going to be neutral. Then do another one for the negative. And this is going to be negative, right? So you're trying to find the ways that makes something negative there, right? The most commonest way, negative. Perfect. So I've gotten them. Now if I check back the positive tweet, if I check it out, it's going to give us only the test, right? Perfect. And now we can actually use counter from collection to be able to get all the words there, right? But you can also tokenize the entire stuff. Perfect. So one of the things that we can also remove all stop words from this, because there are a lot of stop words within our test. So let's see how to do that. So I can just go back again to the same thing that we have, right? We can convert the entire stuff into tokens and then remove all the stop words. So let's make it like this. I'm going to go back again to the same thing that we had. So to be doing that, we will be trying to remove stop words and then convert to tokens, right? So that's what we're trying to do. So the first one is just go back with this, right? It's in positive tweet that we have. Right. Then apply, because it's still a data frame. Apply. What I'm going to do is I'm going to use NFS dot remove stop words. Right, I'm going to remove all stop words. Then later I'm going to convert it to list, right? That is something very simple. So I'm running this simple function to convert the entire stuff. It's good to first of all remove stop words, then convert the entire stuff into a list. So I'll do the same thing for the rest. So let me copy this entire stuff here. So this is going to be negative and then positive, right? So let's make it like this. So I'll run this one again. And let's change this one from positive tweet to positive tweet list. So we know that this is a list and this is now a list, so that it's totally different, right? It's always better to name it so that you know what you are doing. So this is going to be neutral and negative. So negative, and this is going to be neutral. Apologies for how long it has been, but I hope you're going to learn something from this thing. Okay, so this is going to be negative. Right, so we're just doing the same thing on them, right? Perfect. So we're going to get a list of them. Then later we can actually convert the entire stuff into tokens. So if I go back and I check the positive tweet, this now is not without stop words, so I can actually convert this entire stuff. Positive, I spelled it wrong. That's why sometimes you have to just keep the name short. Okay, let's go with this positive tweet list. Said it's not defined. Yeah, let's run it again. And then let's go back. Right, perfect. So that has given us in a very nice format. So now we can now convert this entire stuff into a document. We can now convert this entire stuff into a word list, right? So let's check it out. We can actually remove the emojis. It seems we don't even remove the emojis. You can also remove them in case you want, right? You can also try the same thing. So you can just apply that one to it in case you want. But let's move on straight away, and then let's do a simple count for all the tokens. So this is going to be, let's convert it to tokenization. The entire stuff, so I'll call it as my positive tokens. Let's make it like this, converting the entire stuff. So I just take this entire stuff that we had, this list of positive that we had, we're going to split them into tokens so that we can be able to get a word count for them, right? So this is already a list, so dot, let's go with this. So let's say token for token in this, or there's not tokens, so let's say for line in this, right? They're picking everything, then you're going to split them. So let's make it like this, so that it doesn't confuse anybody, let's make it like this, right? So if I have, so for my line in my positive can spell list, if I go with this print line, I'm going to print them one after the other, right? Because it's a list, right? Pivot. Now what I want to do is, after getting this, I also want to pick every line of them and then split them. So let's say for token in line dot split, I'm splitting them per space. Then I just go back again. You can just split them by space or just go straight away with split without this format, right? Taking off this comma or bracket, automatically just split them per space. That is the default. Then I'll just go with print token. Right. So let's take off this. Let's take off the line and then let's print out only just the token, right? That's what you're trying to do. Right, so perfect. So I'm now just printing the tokens out. So it's going to just split and just print the tokens, and it's going to take a lot of time because there are a lot of tokens there. So we can now convert this entire stuff we have into a list, right? This is just the basic overview. So I just looping through the list, we are splitting them, we are getting the tokens, right? So I can now convert this stuff into a list of tokens. So positive tokens is going to be token first. So we start from this one, the last one, so token, then for token in line dot split, right? That is the first one here, right? So this is the last one here. Very simple. This is one of the ways of doing it, but the best way is just go with this option. So for line in positive tweet list. So what you're doing is that you're just going to go through the entire stuff. So for line in positive tweet, right? And then for token in line split, right? So just as we did this, we are just picking this first one here, which is this one. So for line in positive tweet, then we're going to go on to this for line in line split, then bring it out, right? That is something very simple. So this is going to be a simplest comprehension that is going to have every token within our test. So what I'll do is that I'll just repeat the same thing for the remaining part, for the positive and negative and then neutral. Right, perfect. So that's finished completely. So let's see what you can do with this, what you have. So if I go back and I do with my post tokens, so we have all of them there. So these are all the positive tokens, right? Very simple. So what we do is that we can actually, since they are all tokens, we can just use count collections to help us with that. We can also use word cloud. So let's see the first one with collections. So we'll be trying to work it. So from collections, import counter. So you're using collections counter to help us get the most common words, right? So you're going to get the most commonest keywords there. So get most commonest keywords, right? Can't spell keywords, apologies. Okay, perfect. So that's what you're going to do to help us with that. So I can just create a simple function to help us to make our work easy. So let's go to this option. So get most commonest, or we can just make it simple, get most let's go to get tokens, right? Perfect. And I'm going to specify the document, then the number that I want. So let's pass number, let's say 30, right? Then this is going to go with this option. So it's going to go with my tokens, or let's go to word tokens, can spell, which is going to be this option. So counter, the counter is going to take the docs that we have, which is a list. Then when that's what it's going to take, then now we can just get the most common. So the most commonest token is going to be the word token that we have, dot most common. Now pass in the number there, right? And now we just return the result as a dictionary. So let's go to result as a dictionary, which is going to be most common. This is always going to come as a dictionary, right? So let's check it out. So go back again and let's pass in our stuff. So get tokens for the positive words. Pass in there, right? We are just giving 10, so 30 is the default. It's going to give us the 30 most commonest word, so you must return it, right? We wrote a function but we don't return it. So I just run it again, and then we can now return it to get the result, right? We don't even need to even bring result here. So that's given to us in this particular option, but we want it as in the format of a dictionary. So I can just convert the entire stuff to a dictionary. Dict. Always get things in dictionary. If I go back now, it's going to be in the format of a dictionary, which is better, right? Perfect. So now we have gotten the entire stuff in the format of dictionary. So the highest words within our positive tokens is what? Cases, right? So cases, new, amp, positive, people, new, dev, COVID, pandemic, and you can actually plot this one out, right? Using Seaborn on any of the packages. So let's use Seaborn to plot it, right? So we'll be plotting this particular one that we have. So I'm going to plot Seaborn. So plot with Seaborn. So let's, since we have gotten the concept, so let's do our function. Let's apply the function to every word. So we're going to apply it to the most common positive, right? Something like that. Then we do the same thing for the rest. This is too long, but I hope you are getting it. You are enjoying it. So this is going to be negative, negative. Then try the next one for neutral. Right, so we have negative and then neutral. So this function is going to work on all of them. Hopefully it doesn't make any mistake. Now we can plot it with Seaborn. So we can convert the entire stuff into a data frame. You can actually apply that particular function here to convert the entire stuff into a data frame here, right? So let's do a simple one for, let's say, my neg.df pd.data frame, which is going to take my most common negative. So this is already a dictionary, so now we can just convert the entire stuff. It's giving us an error because we made a mistake somewhere. Let's copy this one here and then paste it here. Yep. Then let's go with items because we want to. Right, you can actually give a, if I run it like that, you're supposed to bring items here, right? So new data frame, and then I said new data frame, negative data frame. Why am I making a lot of mistakes today? Okay, right, so we can actually get everything like this. So this is the words and this is the tokens. We can actually add a score to it. Since it's data frame, I can just go with my columns and specify that I want the first one to be the cases or the words. The next one is going to be the scores. Or the count, right? It can be count, it can be scores. Now if I run it, it's going to be the words, which is the token, and the word, right? So we can apply the same function that we have done to get our plot. But let's plot this one out. So to plot this entire stuff with Seaborn, it's going to be very simple. So I can just go with sns.bar plot. Now passing my values. So let's plot that one out, right? So to plot, it's just going to be Seaborn.bar plot. Then I pass in my s. The s is going to be the words column, right? And then the next one is going to be, that is this particular column, the RSS. Then I'll pass in my y. The y is going to be my scores column, and I'll pass in my data. The data is going to be my negative df, right? So that's just what you're trying to pass. So let's run it again. Going to give us our plot. Voila. So you have gotten our very nice plot of the negative ways and the positive ways, right? Very cool, right? This is okay, but these things are not rightly well, so we're just going to use stick as we did above. So I'll just copy it, save us time because we are taking lots of time, right? And then just run it again, and now it's going to make it better, right? So this is all the negative ways, right? And then the most commonest word within our negative sentiment, which is cases. So cases is the most commonest word within our negative sentiment. And then you have up, people, pandemic, spread, daily, like COVID-19. Right? So these are the most commonest word within our negative sentiment. So you can repeat the same thing you have done for the positive and then the neutral. So let's copy this one here, and then let's repeat it for the rest. So go back again. I'm going to repeat this one for the positive sentiment and then the neutral sentiment. Positive, and do the same thing that we did, the same plot we had here. So one of the ways that most of the time when you're doing this, you can just put everything in the format of, let's say, functions, right? So as you put them in the format of functions, it becomes easy for you. So I'll just change this one from this one to positive. So now we can now plot it. Then do the same thing for the other ones, right? For the neutral. So I'll copy this entire stuff. And you can see from our analysis that this analysis we did, you can see that cases new amp, positive people new, death, COVID, almost the same thing, right? Just following almost the same thing. So is it, let's see, the last one is Trump right here. It's changing here. Okay, that means it's different. And I'll try the same thing for the neutral. So this is going to be neutral, and then this is going to be the neutral. You can actually add a title to it in case you want. So it's giving us a name error because we made a mistake here for the naming. So this is it. So we made a mistake because we forgot the name here. So just change it, and that's going to give us our plot, right? So that is something very simple we have done. Now, since we have been able to do some simple plot of the most commonest word, we can actually do a word cloud of this, right? So we can just convert the entire stuff and then do a word cloud. So let's work on the word cloud. So we have gotten the most commonest words among them. So we can actually do the word cloud. It's another way we can also visualize our most commonest word cloud. It's going to be from word cloud, import word cloud, right? And we are using word cloud to help us with our plot, right? You can also use word cloud. So let's work on it. So let's create a function to help us with that. So def, then let us always make it a function, plot word cloud, which is going to take my document. Then when I take the document, it's going to create my word cloud, which in this case is going to be the word cloud class. So word cloud class, right? And the word cloud class is going to do something. So it's going to, first of all, it's a class which is going to take the function called generate, right? And then I'll pass in my document, right? Perfect. That is a simple function. Now in case I want to plot, I can just go with my plt.im show, which is going to take my word cloud. Then I can just go with interpolation. You can specify the interpolation. It can be bilinear, it can be linear. So let's go with bilinear, right? That is the basic understanding. Then I can just take off the plot axis. So axis off, so that you don't have the axis behind it. You just off, right? And now we can just return the entire stuff. So plt.show. So this is a simple function we have created to help us with our word cloud, right? So what we do is that you must get the word in the format of a string to get it out. So we already had our positive, what is a positive tokens or we had the positive tokens, right? All the positive tokens together. So we need to convert them into a document. So like it's going to be my positive document. Simply by converting the entire stuff into a list, it's going to be this option. Dot join. Now pass the entire stuff there. I'm converting the entire stuff into a document, or a single document I can actually apply. So let's check the first plot to make sure that our function is working. Then I'll pass in my positive docs, right? a pass it that's going to analyze it and give us a very nice word cloud. Take some time for it to run. Hopefully our function doesn't fail us. So that is a simple analysis we have done from scratch. You have seen how to take some tests from a place. You have seen how to analyze them. You have seen how to clean the test using neat test. You have seen how to do sentiment analysis using test blob. You have seen how to use collections to derive some simple insights from it, right? We have seen how to plot the positive ways and negative ways. Of course, there are a lot of things you can do, but this is some of them. So later on, if you will be able to extract all the entities from this particular test, right, that we have. Right, perfect. So our plot has come perfectly well, right? So you have seen that our function is working. So we can also do the same thing that we did for the rest. So I can just go back again, negative docs, do the same thing we did here, dot join negative tokens, then repeat the same thing for the positive, right? So that we all have all of them together as one. So this is going to be neutral. Then this is going to be my neutral documents, my neutral tokens. Right, perfect. Now we have gotten our first plot. You can even make this plot bigger, right? You can add the size to it to make it bigger in case you want, right? So it's going to be figure size to make it bigger. So let's say 2010, right? So we have it together as big as a big plot. Now I can run this particular function here. So plot word cloud, then negative docs. It's going to give us our plot, right? So that's something very simple. So in another session, we'll try and see whether we'll be able to extract all the entities from it. And it's very simple. All we need is just to use maybe Spacey. Then we will use Spacey's name that we're going to extract all the entities from our test, right? So let's write a simple function for that. So whilst it's generating our plots, I'll just try and see whether we'll be able to use that one very quickly, because that's just a simple stuff. So this is going to be entity NER extraction from our test, right? So let's see whether I'll be able to do that. It may take some time for it to get that right. So if you check it out, you can see that we have a very nice plot of all the negative ways. So this is the negative ways. You can see that the pandemic is there, people, active cases, look, all of these things, week, work, said. That is for the negative ways. Virus, daily symptoms. You can also try the same thing for positive words. For neutral, right? Then also do the same thing for the positive words again. Positive, which you have already done, right? So let's recap. So to recap, this is what you have done. So the named entity recognition, we'll do it later another time, right? Because of time. In another video, we'll try and see how to work on that. So the basic idea of what we have done so far is that we took some data from somewhere, and then from JPrada, then we used pandas. We opened the data set, we took only the test column, then we tried to analyze it, right? We saw how to get the value count of where the tweets are coming from. We saw a simple tool to clean our test using the test. We cleaned all our tests. Then later we did some sentiment analysis on our test with this one here, which we used test blob to give us a very nice plot of the number of positive and negative. Then we also did some simple keyword extraction using collections, and then we did word cloud to find. We did a plot of the most commonest word for negative and positive. Then also did some word cloud plots, right? Very simple. So thank you for watching this tutorial. In case you have any question or contribution, you can just put it in the comment section below, and please don't forget to subscribe and check the link below for some more stuff. See you another time. Stay blessed. Bye.